Let us look at question number 41, students. Consider the reaction. So we've been given a reaction sequence and the examiner seems to be interested in the incorrect statement about the compounds X, Y and Z which are formed. So let's try and figure out these compounds which are given to us. So if you look at the first reaction, we have been given a secondary halide which is allowed to react with tertiary butoxide ion in the presence of tertiary butyl alcohol. So this is a bulky base, students, and it will give a Hofmann elimination product. So we are going to get a terminal alkene which is represented by this structure. And now this compound X is subjected to reductive ozonolysis using O3Zn. So students, this reductive ozonolysis is going to convert this into Y and Z. So we're going to have the formation of aldehydes, which is the propanol and methanol or the formaldehyde. Okay, so we're going to have these two aldehydes. Now it is given to us further that Z reacts with ammonia to give us this structure. So we can clearly see that this Z has to be formaldehyde. So this is Z and this is Y, while this was X. Okay, so now that we have identified all of X, Y and Z, we can proceed to the options which are given to us. So option 1 says X on hydroboration oxidation produces a primary alcohol as a major product. So this is correct, students. When X is subjected to hydroboration deboration, let's call it HBO DBO, it is going to lead to the formation of a primary alcohol. If you look at the second statement now, which says that Y can reduce tolerance reagent. So Y is an aldehyde. It can reduce the tolerance reagent and convert itself into propanoic acid. So this is correct, students. If you look at the third statement now, which says that Z is HCHO, this is also correct, students. We had seen that Z was indeed formaldehyde. And if you look at the fourth option now, Y can give positive iodoform test. This is incorrect, students. Y cannot give positive iodoform test. So for this question, we have to select the incorrect statement and we have to mark the fourth option as the correct answer. Let us look at the next question. Question number 42. An organic compound C5H8OCl2 reacts with cold water to form C5H9O2Cl. X on heating with aqueous KOH followed by acidification gives Z, which can show enantiomerism. The possible structure of X is. So if we talk about the compound X which is given to us, we have C5H8OCl2. So we can have the degree of unsaturation. We have the degree of unsaturation equal to 1. And if we talk about Y, Y also has du equal to 1 and Z also has a du equal to 1. So all of X, Y and Z have a du equal to 1. Now if you look at the conditions which are given to us, it says that it reacts with cold water to form Y. So a halide which reacts with cold water, it has to be a acid halide. Only acid halides react with cold water. The normal alkyl halides, they do not react with cold water to give us substitution products. Okay, so we have established that the compound has to be an acid halide. So we can clearly eliminate the first and the third option as they do not react with cold water. If you look at the second condition which is given to us, which says that X on heating with aqueous KOH followed by acidification gives C5H10O3. This also has 1 du as we had seen before, which can show enantiomerism. So on heating with OH minus, what happens is both these chloride groups have been replaced by hydroxyl groups. Now all that is left is to check if the compound can show enantiomerism. Now out of the given options 2 and 4, all that is left is to check if the product can show enantiomerism or not. So if we talk about the second option which is given to us, the Cl is located at the terminal position and this will undergo SN2 reaction and will lead to the formation of alcohol at this position. Now students, this cannot show enantiomerism, so this will also not be an answer. So the answer has to be the fourth option. So we can check the products which are formed. So we have CH3, CH2, CH2, CHCl, COCl. This was X. On reacting with cold water, we're going to have, we just ignore the hydrogens. So we'll have the formation of the structure. And when this X is allowed to react with OH minus in presence of heat, we have the formation of this structure. this is Z, and this can show enantiomerism as the labeled carbon atom is chiral. Okay. So students, for this question we have to select the correct option as option 4. Let us look at the next question. Question number 43. Benzene react with bromine in presence of iron and forms X. You can clearly see that X is bromobenzene. The compound X reacts with limited amount of methyl chloride in presence of anhydrous aluminum chloride to form Y as the major product. So X is allowed to react with methyl chloride in presence of AlCl3. So this is going to form the para compound as major. Halogens are orthopara directing, but they are deactivating. Okay, so this is Y. Now it is given to us that Y reacts with 1 bromopropane. So it reacts with 1 bromopropane in presence of sodium ether. So we have Na in ether. So we have the Wurtz-Fittig reaction now. So this is going to lead to the formation of this structure. So the Na in ether is going to couple the radical formed here with the radical formed here. So we're going to have the formation of this structure. Now if you look at the options which are given to us, we can clearly see that we have to select the third option as the correct answer to this question. Let us look at question number 44 now. In question number 44, we have been told to consider the following compounds. So we have CH3CHO, PHCHO, CH3COCH3 and HCOH. So the examiner seems to be interested in the compounds which do not reduce the Tollens reagent. So students, if you look at option 1, it is an aldehyde, so this will reduce Tollens reagent. Benzaldehyde will also reduce Tollens reagent. Acetone is a ketone, it cannot be oxidized further by Tollens reagent, so this will not reduce the Tollens reagent. And if we talk about formic acid now, HCOH, this will also reduce Tollens reagent as it will get converted itself into CO2. So the carbon is getting oxidized in this case and it will also be reducing the Tollens reagent. So the examiner seems to be interested in the compound which does not reduce the Tollens reagent, so we have to select the third option as the correct answer to this question. Let us look at the next question now. Question 45. The structure of X is given below. We have to select the correct statement about X. So if you look very carefully at the structure of X, we can see that we have a pyranose on the left and we have a furanose on the right. The pyranose given to us is alpha. So we have alpha pyranose as the CH2OH and the OH groups, which is now converted into acetyl linkage. They are trans to each other, and if you look at the furanose structure, we have the CH2OH and the CH2OH which are anti-parallel. So we have a beta fructose or a beta furanose, and we can see that alpha pyranose and beta furanose, these combine to give us sucrose. So the structure which is given to us is that of sucrose. And let us now look at the statements given about X. So option 1 says 1 mole of X on hydrolysis produces 2 mole of fructose. This is incorrect, students. It produces 1 mole of fructose and 1 mole of glucose. X is a reducing sugar. This is also incorrect, students. The hemiacetyl is involved in the glycosidic linkage formation, so it is not reducing in nature. If you look at the third statement now, X on hydrolysis forms a product mixture called as invert sugar. This is correct, students. X is sucrose, and on hydrolysis it is going to form alpha D glucose and beta D fructose. And if you talk about the fourth option, 1 mole of X on hydrolysis produces 2 moles of glucose. This statement is also incorrect, students. It will produce 1 mole of glucose and 1 mole of fructose as we had seen before. So students, for this question we have to mark the correct option as option 3. Moving on ahead to the next question.